Hello everyone, welcome back to our Java programming course. I am Dr. Amit Batra. In today's session, we are going to learn an important real world concept integrating multithreading with database operations. This topic is very useful when we design applications like banking systems, e-commerce platforms, or multi-user web applications where many users access the database at the same time. Before starting today's topic, let us quickly revise what we learned in the previous session. We discussed JDBC, which is used to connect Java applications with databases. We learned about key JDBC components such as driver manager, connection statement, prepared statement, and callable statement. We also studied result set, which is used to store and navigate query results. Additionally, we understood different result set types and concurrency modes and how updatable result sets allow us to directly insert, update, or delete rows from the database. Now let me start with the some important questions. Can multiple users access the same database table at the same time? What happens if two threads try to update the same record simultaneously? And most importantly, how can we ensure safe and consistent database operations when multiple threads are running together? These questions naturally lead to us lead us to today's topic, multithreading with database operations. By the end of this session, you will be able to understand how multithreading works with databases, how multiple threads can safely access a database, and how JDBC connections should be managed in a multithreaded environment. In this session, we will first understand the concept of multithreading. Then we will see why multithreading is required in database applications. After that, we will discuss the multithreaded JDBC environment, and finally, we will see a simple Java example that demonstrates multithreading with database operations. Multithreading means running multiple parts of a program called threads simultaneously to improve performance. Think of your computer, you can listen to music, download files, type in Word, and browse the internet at the same time. Each of these activities is like a thread. Similarly, in Java, multithreading allows a program to perform multiple tasks at once. In Java, there are two main ways to create threads. The first way is by extending the thread class and overriding the run method. The second way is by implementing the runnable interface and providing the implementation of the run method. Both approaches allow us to define what task a thread will execute. Now the question is, why do we need multithreading with databases? Multithreading helps in faster processing, handling multiple clients at the same time, running background tasks like logs and notifications, and performing parallel insert and update operations. All this leads to a better user experience. However, when multiple threads access a database, we must be very careful and use proper synchronization to avoid conflicts. In a multi-threaded JDBC environment, each thread must have its own database connection. We should never share a single connection between threads. Each thread should also manage its own transaction, meaning commit or rollback independently. Every thread should perform its own SQL operation and properly close the connection after use. This approach ensures thread isolation and avoids race conditions. Let us understand the architecture. Thread 1 opens connection 1, performs an insert operation, commits and closes the connection. Thread 2 opens connection 2, performs an update operation, commits and closes the connection. Thread 3 opens connection 3, performs a select operation and closes the connection. So every thread works independently with its own connection. Now let us understand this Java example. Here we have a class called dbThread which extends the thread class. Each thread is assigned a task, either read or update. Inside the run method, every thread creates its own database connection using driver manager.getConnection method. If the task is read, the thread executes a select query and displays student names. If the task is update, the thread updates marks using a prepared statement. After completing the task, the connection is closed. In the main class, we start three threads. The first thread reads student records, the second thread updates student marks, the third thread again reads the records. All these threads run in parallel and each one uses a separate database connection. This code clearly demonstrates multi-threading architecture. Each thread creates its own database connection. Each thread performs performs its own database operation independently. Each thread commits or rolls back its own transaction. And finally, each thread closes its own connection. This is the correct and safe way to use JDBC in a multi-threaded environment. Let us summarize today's session. Multithreading allows multiple tasks to run at the same time. In JDBC, each thread must open its own database connection. Multiple threads can safely perform thread insert and update operations in parallel. Connection isolation is very important to avoid conflicts. This concept is widely used in real world systems such as banking, e commerce servers, and messaging applications. Before we end, take a moment to reflect what was the most useful multi-threading feature you learned today and why. In the next session, we will start a new topic, Introduction to Java Servlets and Servlet Architecture. Now we'll be solving a case-based cum scenario-based programming problem. The problem is in front of us. A hospital management system uses a multi-threaded Java application to handle patient registration, billing, and report generation using JDBC. We have to solve three questions. First question is design a multi-threaded architecture integrating JDBC operations. Second, evaluate synchronization and transaction management strategies. Third, critically analyze performance, scalability, and data consistency concerns. So, a hospital management system must support simultaneous users such as receptionists, billing staff, doctors, and administrators. To achieve high performance, scalability, and data consistency, a multi-threaded Java application integrated with JDBC is used. So, design of multi-threaded architecture integrating JDBC. What are the thread responsibilities? As far as thread types are concerned, first of all, the registration thread is used for patient registration and JDBC operation will be insert. Billing thread generate bills and payments. JDBC operation will be insert or update. Report thread generate medical or financial reports. The corresponding JDBC operation will be the select. Key design principles. First principle is thread per task model. Each request, that is registration, billing, or report, runs in a separate thread. Second principle is connection pooling. Use a data source or connection pool like Hikari CP. Threads borrow and return connections. Third key design principle is no shared JDBC objects. That is connection statement result set are thread local. First of all, we'll be creating a database in our workbench, MySQL workbench, named hospital DB1, and then we'll be using this database using use statement, and then we'll be creating a table name patients with three columns, patient ID, name and age, and then the table bills will be created by us with three columns again, bill ID, patient ID, and amount. Now we are in a position to write our program in our integrated development environment, that is IntelliJ IDEA. So I have created a project named multithreading JDBC example for integrating multithreading with JDBC. So let us start with the code. First three statements are import statements. Import java.sql.star, import java.util.concurrent.executor service, import java.util.concurrent.executors. So first we import the required packages. The java.sql package provides JDBC classes such as connection, prepared statement, and result set. The java.util.concurrent package provides executor service and executors, which we use to manage multiple threads efficiently using a thread pool. Then we are having line number 5, that is public class main implements Runnable. Here the main class implements the Runnable interface. This allows us to define a task that can be executed by multiple threads. Each object of this class represents one hospital operation such as registration, billing, or report generation. Then line number 7, private string task type. The task type variable identifies which operation the thread will perform. Depending on its value, the thread will execute patient registration, billing, or report generation. Then line number 10, public main string task type. This dot task type is equal to task type. So the constructor initializes the task type. When a thread is created, we pass the task name so that each thread knows exactly what operation it must perform. Then line number 15, private connection get connection throws exception There is no need of this statement, so I'm omitting this statement. Class.for name, there is this has become obsolete, so there is no use of this statement. Then we are having return driver manager dot get connection line number 17. JDB as usual we are passing URL root user and disturbance, sorry, password, which is a disturbance $18 in my case. So this method establishes a connection with the MySQL database. The JDBC driver is loaded using there is no use of class.for name, which we have already omitted. Each thread calls this method and gets its own database connection, which is very important in a multi-threaded environment. Then we are having line number 25, that is at the rate override annotation, public void run method. The run method contains the code that is executed when a thread starts. This is the heart of multi-threading. Then we are having line number 29, that is con connection class object con is equal to get connection. Con dot set auto commit, we pass false as a parameter. So each thread opens its own database connection and disables auto commit. This means we are manually controlling the transaction, which ensures data consistency. Then we are having if statement in line number 32. If task type dot equals register, then the register patient method is called, passing connection object as a parameter. Else the task type dot equals billing, generate bill method is called. Else if task type is equals report, generate report method is called. So here the thread checks the task type and calls the appropriate method. Different threads can execute different database operations simultaneously. Then we are having line number 40, that is con.commit, system.out.println, thread.current thread.get name, transaction committed. So if the operation is successful, the transaction is committed and the changes are permanently saved in the database. Then we are having the catch block to catch any exception. So if any error occurs, the transaction is rolled back. This prevents partial or inconsistent data from being stored. Then we are having the finally block, line number 53. If con is not equal to null, con.close. Finally, the database connection is closed. Closing the connection is very important to avoid resource leakage. Then we are having the uh, method named register patient in line number 63. This method handles patient registration. It inserts patient details into the patient's table using a prepared statement. Prepared statements are safer and prevent SQL injection. Then we are having line number 75, method called generate bill. This method generates a bill for an existing patient and it inserts billing details into the bills table. This operation may run concurrently with patient registration or report generation. Then we are having generate report method at line number 87. This method generates a report by retrieving patient names and bill amounts using a join query. This is a read-only operation and can safely run in parallel with other threads. Then we are having line number we are having the main method. This is the entry point. Line number 102, executor service. Executor equal to executors dot new fixed thread pool. We pass three as the parameter. So here we create a thread pool with three threads. Using a thread pool improves performance and avoids excessive thread creation. Then we are having line number 104, executor.execute new main register, executor.execute new main billing, executor.execute new main report. We submit three tasks to the thread pool. Each task runs in separate thread and performs a different hospital operation. Then the last line is line number 108, executor.shutdown. So after submitting our task, we shut down the executor to release system resources. This program demonstrates a multi-threaded hospital management system where each hospital operation runs in a separate thread. Each thread uses its own JDBC connection and transaction, ensuring safe and concurrent database access. The use of executor service improves performance, scalability, and resource management. The program integrates multithreading with JDBC by executing independent hospital operations in parallel threads, each with its own database connection and transaction control. So now we can execute this program. Build process starts and we can see the output in the output window below. So as we can see here, this is the output, that is bill generated, patient registered, transaction committed, and the for the patient Rahul Kumar, bill amount is 3,000 and transaction is committed in the end. So we have successfully answered the part A question. Now we move to part B. Evaluate synchronization and transaction management strategies. So as far as synchronization strategies are concerned, first the question arises, what needs synchronization? That is shared memory objects. Best practices, as far as best practices are concerned, as far as Java objects are concerned, strategy is to use synchronized keyword and reentrant log. As far as JDBC connections as resource are concerned, strategy is to never shared. As far as shared counters or logs are concerned, strategy is to use atomic variables. As far as database records are concerned, as a resource, database locking is the strategy to use. So why not synchronize JDBC code? Synchronizing JDBC blocks kills concurrency. Databases already provide row level locking. It leads to thread starvation. Second is the transaction management, that is manual transaction control. That is the statement connection object con.set auto commit. We pass false as the parameter. So the transaction strategy, as far as operations are concerned, we were having registration plus bill, that is single transaction, report generation, that is read-only transaction, payment processing, that is serializable isolation. As far as isolation levels are concerned, there are three levels. First level, isolation level is read committed, and the use case is in normal queries. Repeatable read isolation level is concerned. Use case is billing, and the last isolation level is serializable, and the use case is in payments. Rollback handling, rollback can occur on payment failure, rollback can occur on partial data insert, rollback can also occur in case of network issues. So now we will be answering the C part, that is critically analyze performance, scalability, and data consistency concerns. So as far as performance analysis is concerned, advantages are parallel processing of patients, faster response time, non-blocking operations. As far as performance risks are concerned, issues, first issue is excessive threads. Impact can be on context switching. Second issue can be slow database queries. It can have impact of thread blocking. Issue of poor indexing leads to bottlenecks. So the optimization techniques are use the thread pools, use the batch inserts, optimize SQL queries, index patient ID and bill ID. As far as scalability analysis is concerned, horizontal scalability increase thread pool size. It also use load balancer. It uses microservices for billing and reports. As far as vertical scalability is concerned, it increased database connections, use read replicas for reports. There are some scalability challenges like first problem is database connection exhaustion. Solution is to use the connection pool. Second problem can be report overload. Solution is to use async processing. As far as problem of high peak traffic is concerned, solution is to use queue-based system. Now, as far as data consistency concerns are concerned, possible issues can be first issue can be dirty reads. Example is wrong bill amount. Second issue can be lost updates. Example is overwritten payments. Third issue can be partial commits. Example is incomplete registration. So consistency solutions are ACID transactions, proper isolation levels, optimizing locking, foreign key constraints. Real world example is patient registration fails, leads to billing must roll back, payment fails may lead to bill status must not update. So the final conclusion is multi-threaded JDBC based hospital management system improves throughput and responsiveness, handles multiple users concurrently, ensures data consistency using transactions, scales efficiently with thread pools and connection pooling. However, improper synchronization, excessive threads, or poor transaction handling can cause deadlocks, data inconsistency, and performance degradation. So, multithreading improves performance, but correctness is ensured by database level transaction management and Node Java level synchronization. Thank you for watching this lecture. Keep practicing and see you in the next lecture. Please like, share, and subscribe for more Java programming tutorials.